Hi everyone. In this video we're going to talk about tangent in the unit circle. In particular, what is the tangent of a terminal arm on the unit circle? So if you watched my last video on sine and cosine in the unit circle, you'll notice a conspicuous absence of any discussion of tangent at all. And if you learned about tangent previously, it was probably in the terms of TOA, right? Tangent of your angle is the opposite over your adjacent. And that's a fine understanding if you are trying to solve for right angle triangles. But there's actually a much more powerful, deeper connection between tangent, sine, and cosine, which is much more useful going forward, particularly into Math 30-1 when you start graphing the functions of these things. And so I'm going to teach you that definition right now, and we're going to solve for tangent in terms of that definition. So you can actually define tangent of your angle theta as the sine of your angle divided by the cosine of your angle. And sine, of course, is your vertical piece, and cosine is your horizontal piece. So you can sort of think of this as a delta y, a change in your y value, from 0 across, up to your, the y value of your point on your unit circle. And then you can think of your cosine as a delta x, your horizontal piece that goes up to your terminal arm. So like if we're talking about this triangle here, this is your delta x from 0 to the cosine of this angle, and the sine is your delta y. It's the height of this triangle. And so the reason I'm using delta y, delta x is that you might have learned this as your slope. So by definition, tangent of theta is the slope of the terminal arm. And if you really understand that tangent is the slope of your terminal arm, then that makes finding the tangent of an angle very intuitive for most of your special cases. So let's start again. Let's just start here at 0 degrees. So we've got 0 degrees here, 180 of course is here, and 360 of course is here. So if we have the tangent of 0 degrees, well, what is the slope of a horizontal line? So tangent of 0 degrees is horizontal. So your delta y, like what's the sine of this value? The sine of that value, of course, is 0 because it hasn't gone up at all. And your denominator at that point doesn't really matter as long as it's not also 0. But your cosine here is 1 because you've got 1 horizontal, right? Because this point here is 1, 0, right? So what's 0 divided by anything is 0. Or you can just know that a horizontal line has a 0 slope. Similarly, what is the tangent of 180? So tangent of 180 is, your terminal arm's going in the other direction, but that's still a horizontal line. What's the slope of a horizontal line? It's 0. And then let's talk about vertical lines, because vertical lines are kind of interesting. Do vertical lines have a slope? So let's call this 90, and this of course is 270. I guess let's do 90 first, because my clockwise bias is coming out, or counterclockwise. So tan of 90 degrees. So this point here is 0, 1. So by definition, right, it is our sine divided by our cos. Our sine is 1, and our cos is 0. What's 1 divided by 0? As internet memes have well prepared you for, you can't divide by 0. This is undefined. Tangent of 90 degrees doesn't exist. You can't do the tangent of 90 degrees because that is a vertical line. Similarly, tan of 270. Tan of 270 degrees is a vertical line. So it is undefined. Okay, so that's horizontal and vertical lines out of the way. Let's talk about our 45s. So we've got a 45-degree angle in each quadrant. So let's go through all of those. In the first quadrant, our 45 is literally just going to be the 45-degree angle. So this is 45 degrees up. And if you know your unit circle, your terminal positions very well. This is root 2 over 2, comma, root 2 over 2, because they're both positive, right? Cosine's to the right, sine is up. and root 2 over 2 is your medium size special triangle value. So that's great and all, but we don't actually need that because a 45-degree triangle makes this isosceles. And since this is isosceles, all that we care about is that whatever value is here is the same as the value over here, right? So this x value is equal to our y value. And so since those two are equal, whatever they are, let's call them, I don't know, and whatever it is, it doesn't matter. Since it's the same thing in both, when we do our slope, our tan of 45 degrees is the same thing over the same thing. And in this case, it's root 2 over 2 over root 2 over 2. But anything divided by itself is 1. So really all that I care about essentially is the sign of this thing. This was positive and this was positive. And the reason we care about the sign is if we go into other quadrants, it's not always going to be a positive slope. So if we look over here, right, if we go through our coordinates of this one, this is going to be, well, whatever they are, I don't care, right? All that I care about is that they're the same because I'm going to be dividing them anyway. And since they're the same, all that I care about is that my cosine is to the left, so it's negative, and my sine is up, so it's positive. So my tangent of this angle here is 45 degrees back from 180, so that's 135 degrees. So my tangent of 135 degrees is going to be positive in my sine value divided by negative my cosine value, and the exact same value, root 2 over 2. But all that I care about is the sign because I know it's the same, so that's going to be negative 1. We could do this even faster if you understand your concept of slope. So I know that my 45 degrees are going to be up and to the right or down and to the right, isosceles. This one here, is this a positive or a negative slope? That's a positive slope. So 225, I know it's a 45-degree angle, so I know it's going to be positive or negative 1. And all that I care about is that tan of 225 is positive 1. And the reason, if you want to go through it, is that our cosine is negative root 2 over 2, and our sine is negative root 2 over 2, and negative divided by a negative is positive, and root 2 divided by 2 divided by root 2 over 2 is 1. And same thing down here. This one, we've got a positive cosine, we've got a negative sine, so we've got one negative sine. So tangent of, let's see, 360 minus 45 should be 315, and that is negative 1. Apparently this is very funny. Okay, so those are your 45s, your horizontal and your vertical lines. Really with tangent, the only tricky ones are going to be your 30 and 60 degree triangles. Okay, so let's go and look at those. Let's do tangent of 30 degrees. So the way we can do this is we can just quickly sketch some axes, and we know that 30 degrees is going to be a triangle like this, right? So this is our 0 degrees here, 180, 360. So 30 degrees is just a little bit up, and so this is positive, positive. My sine is small, and my cosine is big. So it's a half and root 3 over 2. And I know that my tangent is going to be my sine divided by my cosine. Okay, now this looks pretty ugly, but there's actually something really nice about the form we're going to get for all of these, which actually makes this simplify really, really nicely for us. If we notice here, we've got divided by 2, and we've got divided by 2. And it turns out divided by 2 over divided by 2 are actually inverse operations. You've got divided by 2 in your denominator, and you've got divided by 2 in your numerator. Those are opposites of each other. And if you don't believe me, we can actually just sort of expand this out. This is a half divided by root 3 over 2, right? That's literally what division means. So we're dividing these two things. So this is a half times 2 over root 3. And our 2's and 2's cancel. So this is 1 over root 3. That's pretty good. Minor complication. We can't leave us, a root 3 just chilling in the denominator. We need to rationalize this. So we're going to multiply top and bottom by root 3. And we're going to get root 3 over 3. So tangent of 30 degrees is root 3 over 3. Okay, let's try a tangent of 60 degrees. So tangent of 60 degrees, let's start with a quick sketch. I'm only going to draw the first quadrant because that's all I care about in this case. So this is my 60 degrees. So my sine is tall, root 3 over 2. My cosine is short, so it's a half. And I need to do tangent of 60 degrees is my sine divided by my cosine. But I'm actually going to just skip some steps here. Because our over 2's are always going to cancel because they're inverses. So for all of your 30 and 60 degree values, I'm sure you've noticed with sine and cosine, it's always over 2. It's always over 2. And even root 2 over 2 is always over 2. So no matter what you get, your special values are always over 2, which means our over 2 and over 2 are going to cancel. All I care about is the sine divided by the numerator of the sine divided by the numerator of the cosine. Divided by the numerator of the cosine. So that is root 3 over 1, which is just root 3. Now be careful with that. As you saw, I was talking while I was doing it, and I just made a silly mistake. I almost put that over 2. That's wrong. The over 2's and over 2's cancel. All you care about is the numerators. That's just root 3. That's done. So you're either going to get root 3 over 3 or root 3. Some people memorize those, but I don't think you need to, because this doesn't take long to do. You're just figuring out the numerator of your sine and the numerator of your cosine. Let's try some other ones. Let's do tangent of 210. And let's do tangent of 300 and see if we can figure these out. So tangent of 210. So 180 is over here. So 210 is going to be 30 degrees past that. And I'm just going to draw sort of an exaggerated triangle because all that I care about is it wide or is it short? Or is it tall and thin? So my cosine is going to be negative root 3 over 2 because it's wide, and my sine is going to be negative a half. So tan of 210 is negative 1 over negative root 3. My negative over negative cancels, and I'm going to multiply top and bottom by root 3. So this is root 3 over 3. Tangent of 300. Well, let's see. Where's 300? 300 is pretty close to 360. It's 60 degrees back from 360, so that's going to be a tall triangle down here. Since this is a tall triangle, I'm going to have a big negative sine, and I'm going to have a small positive cosine. So this is the numerator of my sine, negative root 3, divided by the numerator of my cosine, which is positive 1. So this is just negative root 3. Let's do tangent. We haven't done second quadrant yet, so let's do, how about we do 120 degrees? So tangent of 120. So I'm going to quickly sketch that. That is 180 over here. So 120 is going to be 60 degrees back, which makes it tall. So my sine is root 3 over 2, positive. My cosine is negative a half. So I'm going to do my sine over my cos. So this is root 3 over negative 1, which is negative root 3. And let's do tan 150. Why not? Tan of 150 is 30 degrees back from 180. So that's going to be a triangle sort of like this. And my sine is small and positive. My cosine is big and negative. So tan of 150 is going to be my sine numerator divided by my cos numerator. So I have one negative sign, which makes the whole thing negative. And since it's over root 3, I'm going to rationalize root 3 over 3. There you have it. That is how you do tangent. So tangent of horizontal lines. Doesn't matter if it's 0 or 180, it's always 0. Tangent of 90 and 270 are vertical, so that's always going to be undefined. the tangent of your 45s, so 45, 135, 225, and 315, all of your 45s, they're either going to be positive 1 or negative 1. All you need to decide is if it's going up and to the right or down and to the right. And then the 30s, the 30 and 60 degree triangles are a little bit tricky. You're going to have to figure out your sine and your cosine. But as you can see, it's not too crazy. Because the over 2s and over 2s always cancel for you, all you care about is your numerators, which makes these fairly quick questions to do. Granted, tangent is by far the hardest of the three, but even so, it's only a few steps. Okay, so I wish you success with your practice, and as always, let me know if you got any questions.